This video we discussed the conventional AM. This is a scheme that applied in AM radios. Before we go to the scheme of conventional AM, let's understand an important concept called overmodulation. Overmodulation is defined as the envelope of the modulated signal, the positive portion, does not have the same shape of the message signal. So let's look at a couple of examples here. I plotted here using the MATLAB. I have a F2 signal sine 2 pi divided by 2 multiplied by t. F2t equals sine pi t plus 0.5. In this case, the frequency of this sine pseudo wave here, that's half hertz, which means that it will take 2 seconds for this signal to repeat itself once. Let's see here. You can see this is a 2 here, and then it repeats itself here. So at time equals 0, the message is at 0.5. A message at t equals to 2, it come back to 0.5 again. So if I multiply F2 by C of t is carrier high frequency. We can see this scheme. What I'm doing here is a DSB SC AM signals. Now let's look at the positive envelope of the modulated signal. That will be this. I'm going to use different color. The positive envelope will be this. Okay. And then if you look at the blue line with the red line is F2. That's the row of the message. You can see in this case, overmodulation happens here because the positive envelope of the modulated signal does not have the same shape of the message. Now I have another example here. F1t equals 2 sine, same thing, pi of t minus 1.5. Okay. If I plot F1t when t equals 0, that's minus 1.5. The minimum value for F1t, that's negative 0.25, and then the maximum is negative 0.15. Okay, so this red line is F1t. Okay. I'm going to do this 1 plus a multiplied by F1t, the green line. 1 plus a equals to 1, which means F1t is lifted up by 1 in the magnitude. Okay, so this is the green line here. And minus 1.5 become negative 0.5, and negative 0.05 become 0.5, and negative minus 2.5 become negative minus 1.5. So everything plus 1 here. I'm going to do the modulation like this. So u of 1t, I use u of t here. I'm going to do 1 plus a f1t and multiply by c of t. Remember, this is our signal here, low frequency, and that's this shape. Now you want to check what is the positive envelope of the modulated. Okay, the envelope is here. This is the message F1t. So in this case, overmodulation occurs. What about if I change F1t as sine pi t, and then still everything the same? You can see here, this is F1t. This is F1t. Start with 0. The magnitude is 1 and minus 1. Right? So this is F1t. I still do 1 plus a F1t. That's a green one here. And then I do the multiplication 1 plus AF1T multiplied by C of T here. And if we look at the modulated signal, the envelope positive portion, you can see in this case, the envelope, it is corresponding to the shape of the message signal. So in this case, no overmodulation. But this is at the borderline here, you can see here. Well, what is the observation here? As long as whatever the portion in front of CFT, if this portion, let's see here, if I do F2T multiplied by CFT, as long as if F2T less than 0, like this portion, overmodulation will occur. The same thing here. If 1 plus AF1T, that's because I multiply 1 plus AF1T multiplied by C of T. So you look at this portion, 1 plus AF1T, that's this green line here. So you can see whenever this green line below 0, here, that's a 0 line here. Okay. It's below 0, then overmodulation will occur. Let's look at here. So the same thing, we multiply by 1 plus AF1T by C of T. So we want to look at this portion. You can see this portion is a green line here. It never below 0. So therefore, in this case, there's no overmodulation occur because the envelope positive portion of the modulus, it is corresponding to the shape of the message. So I summarize here. If I do U of t equals 2 ACMT, overmodulation will occur when MT, whenever MT is less than 0. If I do this, I use different notation, G of t. So we use this whole thing to multiply the amplitude of this cosine. So when this whole thing, this portion, in this portion less than 0, overmodulation will occur, like here. Whenever it's less than 0, the overmodulation will occur because the positive envelope of the modulated signal does not correspond to the shape of the message at all. So we're talking about this message. If I do this, I use different notation, WT now, it will be overmodulated when this portion below 0. Yeah, B can be any constant here. This is exactly what I illustrated here. I plot 1 plus AF1T, and here for simplicity, I said A equals to 1. Now, once we understand the concept of overmodulation, we can talk about the conventional AM now. The conventional AM, it has to be designed that overmodulation does not occur. That's the key. Conventional AM must not be overmodulated because, why? Because at the receiver, a chip receiver is applied to receive this envelope of the modulated signal. So at the transmitter, we have to make sure that this envelope corresponding to the shape of the message.